Okay, so I forgot to mention in the last one about how you would need to enter this in the calculator. So if you were going to enter it on another line, you would need to put parentheses around the 1/2, and to enter a fraction, you can just go 1 divided by 2, close parentheses, to the x power. And then if we graph that one, you're seeing that these are a reflection around the, what's that? Y-axis. Yeah. All right, let's go ahead and what you should do is try to graph the next one, but we'll talk about it now. So if you haven't had a chance to graph it, go ahead and do that. I'm going to use the same typical x values, -2 to 2 inclusive. And so now what's 3 to the -2 power? Oops. 1/9. What's 3 to the -1 power? 1/3. What's 3 to the 0 power? 1. So this is our y-intercept. It's very similar to the 2 to the x, right? 1 to the, or 3 to the first power is 3, and 3 to the second power is 9. Okay, so let's graph those points. So 1/9 is even harder to graph than 1/4 was. It's really close to 0. 1/3, I'm going to go divide it into thirds. We have 0, 0, 1, 1, 3, 2, 9, and we can go ahead and graph this. So now these numbers are increasing even faster than 2 to the x, right? 3 to the x is increasing more quickly, and it's exponential growth because that base is bigger than 1. What is the asymptote? Do we have an asymptote happening? And what is it? Y equals 0. What's the domain? And the range? Yes, 0 to infinity. Okay. So let's talk about some properties of exponential equations. If you have the base is greater than 0 and b is not equal to 1, then if you have two bases to the same power, that means that the powers, and they're equal, right? This is an equation. You have the same base and the powers to two different powers, then that means that the powers themselves must be equal. It's kind of like in the past when we were talking about rational equations, and I said, what's 1/2? If 1/2 is equal to x over 2, and you were like, well, what's x have to be? X in this case would have to be 1. It's kind of a similar concept in that sense. So if I look at these two, we don't know this word logarithm yet. Well, maybe you have some prior knowledge, but we haven't learned it officially. So if we wanted to solve these equations, I have a variable in the exponent. I would need to rewrite 128 as a power of 2. And look at this. We almost got there before when we were listing these numbers. What's the next number in this sequence? Yeah, 128. That means that is a power of 2. 2 to the first was 2. 2 to the second is 4. 2 to the third is 8. 2 to the fourth is 16. What's 2 to the 5th? Okay. What's the next one? And this one is 2 to the 7th. So when we see a problem like this, if we can replace that number with a power of 2, I can write 2 to the 3x minus 1 is equal to 2 to the 7th. Does everybody see how I got that so far? Now, since my bases are the same, what does that mean about the exponents? They're equal. Yes, 3x minus 1 equals 7, which means that I can solve that for x, right? What would you do to solve this for x? Is that right so far? 3x equals 8. Divide by 3. X equals 8/3. Once I find my x and I solve for x, I can always do a check to make sure that works. I plug it in. 2, 3 times 8/3. minus 1. You see where I'm plugging that in for x? What happens when I multiply 3 by 8/3? Don't I get just 8? And then 8 minus 1 is 2 to the 7th, which is equal to 1/28. We just saw that, and you can use your calculator to confirm. Okay, so by the same logic, does anybody happen to know 3? Can I make 81 into a power of 3? Yes. Yes, 3 to the 4th. Use your calculator to confirm. If you're not sure, you could keep trying out different options. So now that we have the same base, we're going to say x minus 1 is equal to what? 4. Good. And to solve for x, what could I do? Add 1 to both sides. I get x equals 5. And if I want to check that, I plug it back in. I get 3 to the 5 minus 1, which is 3 to the 4th. And 3 to the 4th is equal to 81. So that checks out. All right.